And so this is not Vic Champagne's Santa list of salient features and desires. It's really dictated by what I see, and I've had my finger on the pulse for a long time, over 22 years, both in industry, the Department of Defense, and a variety of different business sectors. And so the ideal cold spray system, and I began with this, it should operate in all ranges and temperatures. An ideal system, again, would be modular in construction, such that I can take it apart like a Tinker Toy set, put it back together again, and get it into small, confined places. I would want it to be, you saw evidence of systems now that are portable, that are mobile. They've got to be. There's a lot of push these days, that, as you saw, not just from me, but from a number of talks, high-level VIPs, putting through policy statements about manufacturing at the point of need. It should allow you to do manual repair as well as robotically controlled repair, because there's just some configurations, some remote and confined areas that just don't lend themselves to one or the other. 3D printing, all right? I've said it a million times. I'm saying it again. Got to adapt to that. Cold spray has a niche in that. You got to think of cold spray too, all right? It's not a panacea. It's a tool in the tool chest, all right? Just like lens is, just like E-beam is, just like wire arc additive manufacturing is, but it's got its niche areas. And you've heard a couple of those talks, Vegas is saying, hey, cold spray is the only way you're going to do this. And there's a number of applications, important, critical applications that fall into that regime. And interchangeable heads, too. You saw a talk by Penn State. There's a couple of other talks, too, where the head is interchangeable. So you've got an end effector on a robot. One, you may want to put an NDT sensor on it and take that cold spray sensor off. Cold spray sensor, the cold spray gun off. You may want to put a DED, a thermal spray head on it. You may want to put a grinding disc on it. It should be able to do that, and that way you kind of have a system that can do a number of different operations, and it's like a chameleon. You can use it for a variety of different applications. Through the years, so through my 22 some odd years, all right, and I showed a similar slide to this to my management 20 some odd years ago. And, I said, I see potential in this. We started off with our non-structural repairs. We shot for some very important, expensive, high visibility, high impact applications, which allowed us to have the momentum to get further projects and programs, and the rest is history with the advent of the ARO Cold Spray Center. You see the fact that EWI is setting up a Cold Spray Center of Excellence, which I think is very important for industry, academia, government as well. From there, we went to structural repair, and now we're well on the way to 3D printed parts. And you see in the beginning, we did a lot of parts repair, a lot of coatings. People refer to cold spray as a coatings technology. We know that that's not true these days. And then we tried to optimize process parameters, establish a database, make it lower cost, with the advent of helium recovery, with the advent of engineering powders for specific applications that had higher deposition efficiencies. These are all important for advancing the state of the art and for making the process what? More economical, more feasible to production and manufacturing. Yeah, I see what you mean, if there's a delay. And finally, into 3D printing. And you see a snapshot of some of the, I don't have all the systems there, but you see the systems that run from low, high pressure, and 3D printing. And these are the research areas that I've pointed out, and they're certainly not an all-inclusive list at all. I've spoken to these just now, but again, and I'm going to end with this, the systems themselves have to be flexible. They've got to be adaptable for those reasons that I just gave. They've got to be repeatable. They've got to be reliable. And the systems themselves have to be robust. If I'm on an aircraft carrier and there's sea spray, not only from the systems, but from the powder, and you see how we've addressed those issues, and it's got to be turnkey, all right? And with that, so I could have made, all right, so the acronym could have been RAFT, all right? But you're not going to remember RAFT, all right? But you'll certainly remember that acronym. But anyway, the last thing I want to point out, and actually Aaron Burt, Solvis Global, made this chart for me, but these are some of the things that we're pursuing in terms of making it repeatable, reliable in regards to the cold spray system, calibration on how we plan to incorporate machine learning into the process, and again, this type of approach can not only be used for one system, it can be used for all of the systems. And, I don't want to go into the particulars of all of this right now because I got a call and that VIP is waiting, and my phone's buzzing right now. He's out in a limo. And Aaron Burt is going to do presentations on the student posters. And I am going to end with this. That's where I'm going next week. I'm going to Maine. And so that's my daughter, by the way. That's a good brook. I very rarely catch a trout. She caught a trout, and she goes fishing like once every 10 years. But anyway, with that, let me get that VIP out, and if there's anything else you want to ask of me now. Otherwise, you'll see me at the reception. And again, I think we should give ourselves a round of applause as well, because it's you guys that make this happen. It's been a long, winding road, as John Lennon would say. There's a lot of blood, sweat, and tears that went through qualification initially to get where we are, but we do have a snowball effect, and I'm very anxious for the future, very anxious about 3D printing, very anxious about and excited about structural repair, because that's actually where the big, huge savings are, is in those areas of structural repair. And replacing obsolete, hard to get, long lead time parts. So I will be right back. And with that, Dr. Burt, sir.